Alright, in this section we talk about some more integration, but we use basically word problems. That's another word for applications. Alright, so we know that the marginal cost for a commodity is the derivative of the total cost function. MC bar equals M prime of C, where C is the total cost function. Thus, if we have the marginal cost, we can integrate to find the total cost function. So the cost function equals the integral of the marginal cost function. So if the marginal cost equals this, you just integrate that, 4x plus 3, and you get your answer. Now we know that total revenue is 0 if no items are produced. So R of 0 equals 0. That's always true. But total cost is not necessarily, it's not necessarily C of 0 equals 0. Because when you count up all the costs for producing something, there's a certain fixed cost. The cost of setting up the plant, buying all the machinery, tables, chairs, cash registers, ovens, all sorts of different things you need to buy in order to make some product. And even before you make the product, you have to pay out all that money, and that's called fixed cost. So even if you produce 0 items under a cost function, there is a positive number typically, or 0. It's never going to be negative. All right. So we can't determine the total cost function from the marginal cost unless we have additional information. Typically they'll tell us some situation like in example 1 they say the fixed cost is 10,000. So that way you can nail down what K is. Alright, so they give you the marginal cost is 3x plus 50. You integrate that, you get this. And now we know when you produce 0 items, your cost is simply the fixed cost only, which we know is 10,000. So plugging 0 into the function and setting it equal to 10,000, we solve this and we get K equals 10,000. So now we know where we had our general form of the cost function, now we have our specific form of the cost function. Number 2, same idea. You got the marginal cost and you integrate that, and you got to use U and U prime here. You bring in a 2, so you bring outside a 1/2, or you put outside 1/2. And then when you integrate, you get this guy here, and simplify it down, you finally get to this guy, which is this when you plug in what U equals. Now we know our fixed cost is 11,125, so that you set that equal to the function with 0 in for x. And when you solve it, you get K equals 11,000, so now there's your specific cost function. They ask us to calculate what the cost is of producing 300 items per month, so you plug in 300 and you get 26,625. Example 3, they ask you to find, they say, at what level should this company hold its daily production to maximize profit, which means you need to know the profit function. Now to know the profit function, you have to know revenue and cost. Alright, so they give you marginal revenue and give you marginal cost, so you're going to integrate each one. And you integrate and you get your answer, and then to nail down what K is, you know that R of 0 always equals 0, so you can figure out what the specific function is. Then you integrate the cost function, and you still have the problem with your unknown constant K. By the way, for some of these we're using a capital K instead of a capital C because C could be confused with the cost function. So they tell us when you produce 10 items, it costs $700. So you plug 10 in for X and it equals 700. And when you solve it for K, you get 100. So now you know your cost function, you know your revenue function, and you can take the difference, and that's your profit function. Now if you want to maximize profit, you take the derivative, set it equal to 0, and solve, and you get 25. Now to verify that that's a maximum, you can do one of two things. You can do a sign diagram and check values on either side of 25 and look to see if it's a max or min, or you can take second derivative test, take second derivative, and if it's negative, that means it's a maximum. And it is negative, so we know that that is a maximum profit. Note that we can find X equals 25 by solving the marginal revenue equals marginal cost, but we can't confirm that that is actually a maximum until we solve it like we did above. Example 4, marginal revenue equals this, marginal cost equals this, marginal revenue equals that. They tell us fixed costs are this, and the production is limited to 180,000 units. So we're going to integrate cost. Got to use u and u prime here. You got to adjust it a bit, and then we finally get to here, or get to this guy here, and we plug in 0 for x, and we know that will equal our fixed cost, which we know is 100,236. But remember, these values are in terms of hundreds of thousands. So 100,236 is really 100.236. And when you solve this, you get approximately negative 100. So that's your cost. And now you do the same thing with the revenue. You integrate that, and you nail down what k is by knowing that r of 0 always equals 0. And you figure k equals negative 1. So now there's your revenue function. And now you graph both of these guys, and you can see they are equal to each other at some point. If you take the difference between these two guys, you get this here. And remember, we're limiting ourselves to 180. And if you plug in 0 into the profit function, you get a negative profit, actually a loss. If you plug in 180, you get a number of 85.46016. Now if you graph this function, you'll see that it's forever increasing. It doesn't have a relative extrema, no relative max or min. And so the endpoints are going to tell you which one's going to be your maximum. And since this one's the larger one, that's your max. And it's in thousands, so it's $85,460.16. 180,000 units, so 180,000. Now we talk about national consumption and savings. So they let the variable y equal your national disposable income, meaning your income. And c of y is the national consumption function. It means how much you spend. All right, and the dc dy or y or c prime is the marginal propensity to consume. If s equals your savings, then the national disposable income y here equals your consumption plus your savings, meaning your income is the money you spent plus the money you saved. Right, the two of them together add up to your total income. You spend some money and you save some money in your bank account. Alright, so basically y equals c plus s. Now if you solve this for s, you get s equals y minus c. And when you take the derivative, you now find the marginal propensity to save, because s is the saving function. So the derivative is the marginal propensity to save, and derivative of y is 1, derivative of c is dc dy. So marginal propensity to save is this formula here. We'll use this in example 6. So if they give you the marginal propensity to consume here, and you write it this way, now you multiply both sides by dy, you get this guy, and now that's exactly what you have to integrate. So when you integrate, you're going to get the cost function, and you get this guy here. But we also have to nail down what the constant is. Well, they tell us that when the national disposable income is 0, the national consumption is 6. So you plug in 0 for y and you get 6. And you solve that and you figure out that k equals 6. And there you go. That's your national consumption function. Example 6 uses what I was talking about earlier, which was about the marginal propensity to save. And they tell us that marginal propensity to save is 0.25. And so 0.25 equals 1 minus dc dy. So dc equals, when you subtract 1 and then multiply by negative 1, you get 0.75 equals dc dy. So then you integrate that, and you get this, and now we know that when y equals 0, c equals 9. So y equals 0, c equals 9. You solve this and you get k equals 9. So now you know the specific national consumption function. Alright, so let's look at about 12 questions here that are the similar questions to the ones you'll see on WebAssign. So if they give you marginal cost equals this, and they give you fixed cost at 200, you integrate that. and then you nail down what the cost is by letting x equals 0 and it equals 200. And so then you finally nail down what your cost is. You integrate your marginal cost, and then you nail down what the k is by knowing that when x is 10, c of 10 is 300. So you plug all that in and you solve for k and you get 80. So there's your cost function. Same idea here. You're going to integrate this guy and you get this here. And to nail down what k is, you let x equal 100 and the entire formula equals 25,000. So plug in 100 for x and equal 25,000, and you end up getting 10,900 for k. So there's your cost function. And they also, by the way, ask you what your fixed cost is. That's when x equals 0, and so your fixed cost is 10,900. On number 9, they ask you to find the profit or loss from producing 5 and how many will produce a maximum profit. So if you want to know maximum profit, you got to know revenue and cost first. So marginal revenue is this, and you integrate, nail down what k is. And then marginal cost is this, and you integrate, and then nail down what k is. And now you've got you got revenue, and you got cost. Okay, so you take the difference between them, and you get your profit. Now they ask you what's the profit on 5 units, so you plug a 5 in there and it's $3,120. Then they ask you where's maximum profit, so you take the derivative, set it equal to 0, and when you solve it you get 896. Now how do we show that that's actually a maximum? Well, we check with using a sign diagram. I could have used the second derivative test, but I used a sign diagram here. So I plugged in a number in here, namely 1. I plug a number in here, 900, and I got plus minus, so that is a maximum. So 896 units will maximize your profit. Number 11, they give you C bar prime, and they ask you to find C bar, so you got to integrate. And when you integrate, you get to this, and then you nail down what k is by letting x equals 6 and the function equals 10. That tells you k is 8. Right, so there's your function. And then they ask you what's the average cost of 12 units, so you just plug 12 in there. Same thing here with number 12. We're going to integrate this guy. And when we do, we get a constant. And we nail down what the constant is by knowing that 10 units produces $20, equals $20. So you plug in 10 for x and 20 for what it equals, and you find k equals 18. So now you've got your average cost. Now what's the average cost of producing 20 units? Well, you plug 20 in there and simplify it, and you get $20.50. 15, your national consumption is C. And we know C of 0 equals 7. We'll use that a little bit later. So our marginal propensity to consume equals 0.80. And we integrate that and we get 0.80y plus k. And now we use the C of 0 equals 7 to nail down what k is, and k ends up being 7. So there's your national consumption function. So here's your C prime. So you're going to integrate that, and you got to nail down what k is, and we finally do. K equals 8, and now there's your national consumption function. 21. Again, we integrate the function they give us here, and we have to use u and u prime there to do a little manipulation there, but we introduce the -2 and multiply by 1 over -2. And we finally get to this guy here, and we nail down that when 0 items are, when y equals 0, the answer equals 5.65. So you multiply all this out and you get k equals 5.15. And so there's your function right there. 22. We take the integral of this guy. We have to do a little bit of u prime here to get to it. And we finally integrate, and then we have to nail down what k is by knowing that C of 0 equals 9.5. that lets us know the k is 7.5, so there's our function. 23, this one's a little different. 23 and 25 are talking about saving function. The marginal propensity to save is 0.15. Now we know that the saving equals your equals y minus c, and so when you integrate each one, you get s prime, you get 1, and you get c prime. And so when you solve this, you subtract 1, multiply by -1, and you get c prime equals 0.85. So now you integrate that, okay, and now you have to figure out what k is, and we know that c of 0 equals 0, or no, c of 0 equals 5.15. So when you plug in 0 for y, you figure out k is 5.15. So now there's your national consumption function. So it takes a little bit of work, but we're using this idea here. So we take the s prime that we know here, and then we can isolate c prime, and that's what we're going to integrate. So again, this is given here, and so we can plug that in for s prime, and we can solve for c prime. So we subtract 1, multiply by a -1, changes the sign of everything, and now you got c prime equals this, and that's what you're going to integrate. So you integrate each part, and you finally get to here, plug in what u actually is, and we know that c of 0 equals 12, so that allows us to nail down that k equals 12. And there we go, that's our national consumption function.